Automata theory. Automata theory is a branch of computer science that deals with the operations are determined previously, and it is an abstract machine. Abstract machine is not a physical device. It means that a machine which performs a function according to the predefined set of coded instructions. It have four different types of machines, namely combinational logic, finite state machine, push down automaton, and Turing machine. Combinational logic is the basic thing in the machine, which is used to build the circuits that produce specified output for certain inputs. It only returns boolean value, either it may be 0 or 1, or it may be true or false. Finite automaton can only remember finite amount of information. It can have finite number of states. Push down automata. Push down automata remembers only infinite amount of information. We can discuss it later. Turing machine. Turing machine is an abstract machine. As I said earlier, machine is not a physical device. It manipulates the symbol only on a strip of tape according to the table of rules. Infinite tape. Infinite tape, which is in a memory, which can be divided into the cells. Then we can discuss detail the description of pushdown automaton. Pushdown automata is a way to implement the context-free grammar. It can remember an infinite amount of information. It is a combination of finite state machine and a stack. Stack has two operations, namely push operation and pop operation. Push operation is used to insert an element into the stack. Pop operation is used to delete an element from the stack. Another important thing in stack is top pointer, which points the current input of the stack. Pushdown automata has three components, namely an input type control unit, a stack with the infinite state. The user can give the input in the input tape and it will take to the finite control unit. The stack symbol only push or pop the input values and it can be controlled by the finite control unit. Then it can be accept or reject. Then we can move on to the formal definition of the PDA. It have 7 tuples, namely Q, sigma, tau, del, Q naught, Z naught, F, where Q is the finite number of states. As we can see the example in right side, we have two different types of states, Q naught and QF. Del is input alphabet, which may be a zeros or ones, or it may be A or B, any input symbol which can be taken as sigma. Tau is a stack symbol which is used for stack operations. Del is a transition function which can be number of finite states. Q cross epsilon. Epsilon can be included in the sigma and cross tau symbol. We can combine the number of states and input alphabet and the stack symbol. We can get the Q cross of tau star. Q naught is the initial state of the states. In the example, you can see Q naught is the initial state and QF is the final state. Final state is always having circle encircled with another circle, and Z naught is the initial stack symbol. As we can see a symbol like you can have a memory like this stack. In initial state you can have the Z naught in the stack, which mention the initial stack top of the symbol. In this, the stack will be empty. The top pointer will be point in this state. In the example, you can see A comma B moves to C. A is an input symbol and B is a stack top symbol. It may be Z naught or anything. C is a push symbol. Then we can see the example. Construct a PDA that accepts language of 0 power n and 1 power n. N is greater than or equal to 0, which means that it can accept epsilon also. If we want to construct a PDA, we first do four things: problem description, transition diagram for PDA, transition table for PDA, and checking the validity of a string. First, we can move to the problem description. In this problem, 0 will be the first symbol which can enter into the stack. If you encounter the input 0 and the top is null, directly push into the stack, and it may be iterate. It can be number of times, the n can vary. It may iterate based on the n. If you encounter the input 1 and the top is 0, means that pop the 0 from the stack, and this may also be iterate based on the n. The process is repeated until the blank space is came, because blank space is the end of the string that we stored in the stack, and Z0 is the stack's input state, and otherwise the string is valid. Example for transition diagram of PDA. Initially Q0 and Z0 is placed. Then initially the stack is empty, so Z0 will be placed. The stack symbol Z0 is mentioned. If we push an element 0, the element will be included. If number of times the Z0 will be incremented, so the 0 will be pushed into the stack. The top pointer will move each push operation. If we encounter the symbol 1, then it pops the first 0 and the top pointer will move here. Then if we encounter the another 1 symbol, the second 0 will be popped out and the top pointer will be moved here. If the 1 again came, then the last 0 will be popped out. Here the end of the symbol blank will be the top of the Z0. So the string is valid string. Here number of inputs are same, zeros and ones are same. Then transition table for PDA. In Q0 we perform only one transition, that is from Q0 is 0 is an input symbol and Z0 is a stack symbol. It moves to the next state Q1. It becomes the 0 Z0. In this operations we push 0 into the stack. Then in the Q2 we have two transitions: push operation of 0 and the pop operation of 0. In this, if many times 0 comes, the push operation will be performed and 0 will be stored into the stack. If we encounter the input symbol as 1, we pop the 0 from the stack and it can be expressed in epsilon. Here popping the 0. Then if again 1 comes, pop the 0 and the process will be repeated, iterated based on the n operations. If we encounter blank space and Z0, the string will be accepted, otherwise the string will be rejected.